Hello everyone, welcome to the Desmos practice slides for Module 1, Topic 1, Lesson 2, a sort of sorts. And we're going to start this by looking at the graph of a function and determining if it is increasing, decreasing, constant, or some combination of those. So we are ready to go, so we press this blue button here, and we'll be asked this question. Which of these best describes the graph to the left? Is this increasing, decreasing, constant, increasing then decreasing, or decreasing then increasing? A lot of words there. It'll make more sense in a second if it doesn't already. So we want to look at this red graph that we see over here. And in this case, this is a linear function. And the way we want to read this is we want to start from the left side of the red graph and trace it all the way over to the right side. And our question is it going upward, which we describe as increasing? Is it going downward, which is decreasing? Or holding steady, which we call constant? So in this case, again, we go left to right, just like you would read, and we see that it's always going up. So this would be an increasing function. And we can check our answer, and we find that we are correct. We ask for a new problem, and again we trace from left to right, and we find in this case that it never changes. It doesn't go up, it doesn't go down. And when I say going up or down, what we're really talking about is the y values of all the points on that line. So in this case, they all stay the same. It's constant. Constant means unchanging. So it doesn't go up or down, so we would say this is constant. Here we have another increasing function. And now, this one, very interestingly, does some other things for us. So as always, we start from the left, and then we trace it left to right, and we want to determine what is it doing at each spot along the graph. So here we can see this starts by decreasing, and then once we get to this point right here, it changes and then starts increasing. So for this one, we would say that it decreases, then increases. Here we have another straight line, and there's a particular example I'm wanting to get to. Here we are. So this is called an exponential function, and it has this sort of characteristic hockey stick shape, easy for me to say, this hockey stick shape that we have going on there. And while it's very tempting to say that this is decreasing and then constant, because that looks for all the world like it's flat down there, these exponential functions are always either increasing or decreasing. And here's why. The way this exponential function works is that you are multiplying one y value by some other number, which we will learn later is called a common ratio. And so when we have one that's decreasing like this, which by the way, this is a decreasing function, what happens is that I'm multiplying by a number less than 1, which is another way to say I'm dividing by a number. So suppose my function is at 25, and I'm going to divide by 5. 25 divided by 5 is 5, so it would go from 25 to 5. Well, then I would divide by 5 again. 5 divided by 5 is 1, so it would go down again. 1 divided by 5 is 0.2, so it goes down again. And no matter what, if I keep dividing by 5, that number will always get smaller and smaller and smaller. It will never stop getting smaller. Now, it will never get to 0 either, but it will also continue to shrink no matter what. And we'll get to a point where the amount that it shrinks by is so small that you can't even see it on the graph, but it's still happening. And so for this exponential function, this one would be decreasing. You can also have an exponential function that is increasing as well. So one thing I want to point out as we will learn these function families as we go is that certain functions are always either increasing or decreasing or some combination. So let's start with the increasing and decreasing functions. Linear functions And exponential functions, easy for me to spell, right? Linear functions and exponential functions will always be either increasing or decreasing. If you have a straight line that is flat, we can say that that is a constant, but we've given that its own name. We called it a constant function. So we can have a constant function, which is just flat, or if we're looking down here at these options, this will happen with quadratic functions, which remember are the U-shaped beasties, and this will also happen with linear absolute value function. So a linear absolute value function, remember, is shaped like a V, quadratics are shaped like a U, constant is flat, exponential is our hockey stick, and linear, of course, it's just a straight line. And so depending on the function type, it'll have one of these properties. So that can also be helpful if you can identify those. So I hope this will help get you through that first slide. You need to get 15 of these correct to get full credit. And as always, if you are struggling, seek help from a teacher.